Hello students, welcome to this lecture one some applications of trigonometry. So in this lecture we will study exercise 9.1 and if time permits then we'll discuss summary of this chapter. Okay, so here we'll discuss exercise number 12. So our exercise number 1 to 11 that we have discussed in our previous lecture. Okay, so here in this exercise here we have from the top of a 7-meter high building, the angle of elevation of the top of the cable tower is 60 degree and the angle of depression of its foot is 45 degree. So here we have to determine the height of the tower. So let us solve it. So here we let AB be a building and CD be a cable tower. Okay, so here AB be the building and CD be a cable tower, and from this triangle ABD, here AB by BD, this is equal to tan 45 degree, and it implies 7 by BD is equal to 1 since AB is equal to 7 meter. Okay, so BD is equal to 7 meter, and from this triangle ACE, here CE by AE, this is equal to tan 60 degree. Okay, and here AE is equal to BD is equal to 7 meter. So it implies C by 7 is equal to root 3, and it implies C is equal to 7 times root 3 meter. Okay, and CD is equal to CE plus ED, and it is equal to 7 times root 3 plus 7 meter, and this is equal to 7 times root 3 plus 1 meter, and therefore the height of the cable tower is 7 times root 3 plus 1 meter. Okay, so now let us move to another example, another exercise. So in next exercise here we have as observe from the top of a 75-meter high lighthouse from the sea level, and the angles of depression of two shapes are 30 degree and 45 degree. So if one shape is exactly behind the other on the same side of the lighthouse, then we have to find the distance between the two shapes. Okay, so basically what we have given here, so here we have given as observed from the top of a 75-meter height lighthouse. So here we have given height of the lighthouse is equal to 75 meter from the sea level. Okay, and here we have given angle of depression of two shapes that are 30 degree and 45 degree. Okay, and here we have given this information: if one ship is exactly behind the other on the same side of the lighthouse, then here we have to find the distance between the two ships. Okay, so let us see how to solve it. So here you can see this figure. So in this figure here we let AB be the lighthouse and the two ships be at point C and D respectively. Okay, so in triangle ABC, in this triangle here AB by BC, this is equal to tan 45 degree. Okay, so then in this triangle AB by BC, this is equal to tan 45 degree, and we know the tan 45 degree is equal to 1. So AB by BC, this is equal to 1, and here the height of the lighthouse is equal to 75 meter. So 75 by BC is equal to 1, and it implies BC is equal to 75 meter. Okay, so here this distance is 75 meter also. Okay, and now if we take triangle ABD, so in triangle ABD, here AB by BD is equal to tan 30 degree. Okay, and BD can be written as BC plus CD. So, and we have also AB is equal to 75 meter since the height of the light is equal to 75 meter. Okay, so AB by BD is equal to tan 30 degree, and we know the value of tan 30 degree is equal to 1 by root 3. So AB by BD is equal to 1 by root 3, and here we can put the value of AB is equal to 75 meter and BD can be written as BC plus CD. Okay, so 75 by BC plus CD is equal to 1 by root 3. Okay, and here we also find the value of BC, that is equal to 75. So 75 by 75 plus CD is equal to 1 by root 3. And from this equation we get the value of CD, so it implies 75 times root 3 is equal to 75 plus CD. Okay, and it implies CD is equal to 75 times root 3 minus 1 meter. Okay, so therefore the distance between the two shapes is 75 times root 3 minus 1 meter. Okay, so this is our final answer. So now let us move to next exercise. So in next exercise, here we have a 1.2 meter tall girl sports a balloon moving with the wind in a horizontal line at the height of 88.2 meter from the ground, and the angle of elevation of the balloon from the eyes of the girl at any instant is 60 degree. After some time, the angle of elevation reduces to 30 degree. See figure 9.13. Here this you can see this figure. So here basically we have to find the distance traveled by the balloon during the interval. So we have to find this distance. Okay, so let us solve it. So here let the initial position A of the balloon changes to point B after some time, and CD be the girl. Okay, so here CD be the girl, okay, and here triangle ACE, CD be the girl. So from in triangle ACE, here AE by C this is equal to tan 60 degree, and it implies AEF minus EF by C is equal to tan 60 degree, and tan 60 degree is equal to root 3, and here we have AF this is equal to 88.2, and EF this is equal to 1.2. okay, and 88.2 by 88.2 minus 1.2 divided by C is equal to root 3, and it implies 87 by C is equal to root 3, and it implies C is equal to 87 by root 3, and this is equal to 29 times root 3 meter. Okay, so CE is equal to 29 times root 3 meter. Okay, and in triangle BCG, here BG by ACG is equal to tan 30 degree, and it implies CG equal to 87 times root 3 meter. Okay, so distance traveled by the balloon is equal to EG, that is equal to CG minus CE, and this is equal to 87 times root 3 minus 29 times root 3 meter, and this is equal to 58 times root 3 meter. Okay, so now let us move to next exercise. So in next exercise, here we have a straight highway leads to the foot of a tower, and a man standing at the top of the tower observes a car at an angle of depression of 30 degree, okay, which is approaching the foot of the tower with a uniform speed, and 6 seconds later the angle of depression of the car is found to be 60 degree. And here we have to find the time taken by the car to reach the foot of the tower from this point. Okay, so let us see how to solve it. So here you can see this figure. So in this figure, here we let AB be the tower. So here AB be the tower, and initial position of the car is C. So this is our initial position of the car, and which changes to the point D after 6 seconds. Okay, so initial position of the car is C, and after 6 seconds it changes its position to D. So in triangle ADB, in this triangle, here AB by DB is equal to tan 60 degree, and it implies AB by DB is equal to root 3, and it implies DB is equal to AB by root 3. Okay, so DB this is equal to AB by root 3, and now from triangle ABC, here AB by BC this is equal to tan 30 degree. Okay, and here BC can be written as BD plus DC. Okay, so AB by BD plus DC is equal to 1 by root 3, and it implies AB times root 3 is equal to BD plus DC, and we get the equation BD is equal to AB by root 3. Okay, so AB root 3 is equal to AB by root 3 plus DC, and here it implies DC is equal to AB times root 3 minus AB by root 3, that is equal to AB times root 3 minus 1 by root 3, and this is equal to 2 times AB by root 3. Okay, so this is equal to 2 times AB by root 3. So DC is equal to 2 times AB by root 3. So now time taken by the car to travel distance DC, this is actually 6 seconds. Okay, so 2AB by root 3 is equal to 6 seconds. So time taken by the car to be travel distance DB, that is equal to 6 by 2 times AB by root 3, that is equal to 6 by 2 times AB by root 3 into AB by root 3. Okay, and that is equal to 6 by 2, that is equal to 3 seconds. Okay, so time taken by the car to travel distance dB, this is equal to 3 seconds. Now let us discuss summary of this chapter. Okay, so now we will discuss summary of this chapter. So in this chapter we have studied the following points. So first we have studied the line of sight, that is actually the line drawn from the eye of an observer to the point in the object viewed by the observer. Okay, so line of the sight is the line drawn from the eye of an observer to the point in the object viewed by this. That means if we have here some observer and he was seeing some object here. Okay, so this line is called line of the sight. Okay, and the angle of elevation of an object viewed is the angle formed by the line of sight with the horizontal line. Okay, so this is our horizontal line. So here this angle, and this is our light of sight. So this angle that is formed by line of sight and horizontal, that is called angle of elevation. Okay, so the angle of elevation of an object viewed is the angle formed by the line of sight with the horizontal when it is above the horizontal level. Okay, and that is the case when we raise our head to look at the object. So when we raise our head to look at the object, that case we get angle, that angle which is called angle of elevation. Okay, so angle of elevation of an object viewed, that is the angle formed by the line of sight and with the horizontal. Okay, and when it is above the horizontal level, that case we get angle of elevation. Okay, and then we have studied in our previous lecture and in this lecture the angle of diffraction of an object viewed is the angle formed by the line of sight with the horizontal. Okay, so the angle of diffraction of an object viewed is the angle formed by the line of sight with the horizontal. Suppose our observer is here somewhere here. Okay, so here we have our observer, and the observer viewing something here, some object here. Okay, this is our object. So the horizontal is this, and this angle is called angle of diffraction. Okay, so when we get angle of diffraction when it is below the horizontal level. So this is our horizontal level. So when it is below the horizontal level, that case we get the angle of diffraction. So in this case, when we lower our head to look at the object, that case we get the angle of diffraction. Okay, then we have studied in our previous lecture the height or length of an object, or the distance between two distinct objects can be determined with the help of trigonometric ratios. Okay, so that we have discussed by some examples, and then we solve some exercise. Okay, so the height or length of an object or the distance between two distinct objects can be determined with the help of trigonometric ratios like sine, cos, tan, cosec, cot. Okay, so basically we have to use our suitable trigonometric ratio for finding distance or height of an object. Okay, now here we'll discuss example 1, heights and distance, for clearing your concept. Okay, so from a point on a bridge across a river, the angles of diffraction of the banks on opposite sides of the river are 30 degree and 45 degree respectively, and if the bridge is at a height of 3 meters from the banks, then find the width of the river. Okay, so here you can see this figure. So in this figure 9.10, A and B represent points on the bank on opposite sides of the river, and so that AB is the width of the river, and P is a point on the bridge at a height of 3 meters. Okay, that is dp this is equal to 3 meter, and we are interested to determine the width ab. Okay, so we here interested to find the width. So you can see the figure 9.10 of the river, which is the length of the side AB of the DAPB. Okay, so now AB this is equal to AD plus DB, and in right angle triangle APD, here angle is equal to 30 degree, and so tan 30 degree is equal to PD by AD. Okay, so tan 30 degree is equal to PD by AD, and that is 1 by root 3 is equal to 3 by AD, or AD is equal to 3 times root 3 meter. So also in right angle triangle PBD, here angle P is equal to 45 degree. So BD is equal to PD is equal to 3 meter. Okay, so BD is equal to PD is equal to 3 meter, and now AB is equal to BD plus AD, and this is equal to 3 plus 3 times root 3, that is equal to 3 times 1 plus root 3 meter. Okay, so therefore the width of the river is 3 times root 3 plus 1 meter. Okay, and now in